Hi, my name is Michael Warner, and this is a re-recording of a presentation I recently gave to the IEEE Spatial Workgroup. That group is exploring the creation of a standard for if you take HTML for web pages, this is HSML, Hyperspace Modeling Language, that would allow us to extend the virtues of the internet to an internet of everything. So it's not just hyperlinks between texts, it's kind of massive scale planetary lattice of all things. And in effect, it could hold out the possibility of creating a smart economy where today agency is at an individual, family, community, kind of governance, and even firm level. Imagine the economy itself being imbued with a kind of Leviathan-like collective intelligence of our shared will, consensusly curated and so on. So this is just talking not so much about whether we should do that or whether that's a good thing. It's just talking about the technical capabilities and hopefully sort of shaking out the architecture of that from an atomic level, like what would the protocol look like, and then sort of a cosmological level, like how could these mathematical lattices, and I present a few here as possible candidates, help create that kind of global scale kind of intelligent planet effect. And I just want to call out that this is very early, and the point of this video is to support a PDF that has all the links, and I'm doing it in response to requests for people to kind of get the talking aspect of the slides readily available. So the overall presentation, I'm going to go through it as quickly as I can, keep as close as I can to 20 minutes, but it covers kind of holographic digital twins. It introduces the concepts of mereology from mathematics and holons as ways of thinking beyond taxonomies. Then it gets into the Satori protocol, which is a subset of HSML, a proposed subset of that, and explains how that would tie to a global augmented intelligence architecture through the adaptive serialization of geometric structures. So those serial numbers you see on different things, barcodes and such, they could, in a sense, carry intelligence through this. There's a section 2.1 is into some of the math associated with it. And hopefully these will be tools that will help you kind of get a bearing and even sort of an orientation on what could be a solution in this space. I tie that to that protocol and explain how that would create these metasystems that would enable a smart economy. And then finally, not finally, I touch on what are called digital object architectures, distributed autonomous organizations, and then what's called the distributed identifier, and how those would work with protocols, Satori, Atlas, a kind of global digital twin, then the global augmented intelligence architecture, and then this concept of avatars, or different agency intent fabrics that individuals could participate in, all embedded in the hyperspace / transfer modeling language. That brings us to kind of the end where we kind of try to shake out the intelligent economy and what that would look like for a smart planet. And the theme of the event was Society 5.0, and that's kind of the feverish dream is how do we, that Dorothy has, is how do we get there? So here, first, taxons, mirons, and holons. These are kind of the lions and tigers and bears of ways of thinking about systems. For the longest time, many of us kind of live in the world taxonomies. Mereologies and holons are really the new thing here. So taxons, they're in biology, species is a member of kingdoms and all the intervening layers. CEO to janitor, we live in taxonomies, org charts, parent to child, that is both physical in life and also, technically people talk of parent-child relationships in code. And then finally, we see this in file and folder constructs that pervade today in the way we think about information. Now, mirons were invented by mathematicians about 100 years ago in the Erlang program attempt to understand the interconnections between different types of mathematics. They realized that taxonomies couldn't do it. You couldn't just put geometry and algebra over here and calculus over there. They all have these complex and beautiful interrelationships with each other, so they introduced the concept of the meron, which is a part-whole relationship. So it's not just the relations between the parts in the whole, but between parts and parts and holes, and so on. I'm going to go rather quickly through these next slides, but these are really beautiful and enriching diagrams to focus on. The PDF has the direct links to source. These were actually made by architects. I think they did a really good job of expressing these mathematic concepts, but there's this sort of top level mereological relations, some of which should be very intuitive. There's also sort of a subset of those, kind of the whole to part, and then whole to whole, and then parts to parts. The key takeaway from this is that if you're speaking in just a sort of linear top-down, bottom-up vector, that will fail to provide sufficient surface to grasp complexity sufficiently to actually solve problems. So we need this mereological way of approaching things. That brings us to the holon, which is a subject of the standard, the paper, and it's a sort of a way of thinking. And it was originally introduced by Arthur Kossinger, I think, is the guy who coined the term. And you can think of it as something that is simultaneously a whole and is in and of itself, as well as being a part of a larger whole. And this seems to be a very beautiful way of thinking about systems where any given entity, and it's really hard to capture this in technology, in databases, there's an insideness and outsideness to any given thing, unless you're talking about a Mobius strip, for example. And that's really critical to understanding things. We do indentations in spreadsheets, but having more seamless access to that holographic aspects of systems, and that just means sort of whole system, writing to the whole, or holotropic, or going towards the whole. That's going to be necessary at multiple scales of society and individual existence there. So again, the hyperspace markup language, here it is. I'm going to be connecting it to this geometry and this Satori protocol, and we'll talk about that. Before we go into that, what we're really, the paper, the standard document currently references Leibniz, and I found the diagram on the right. I thought that spoke to it. I just want to call out that really we're talking about kind of a universal characteristic, that these are Leibniz words, sort of an alphabet of human thought. And I want to say up front that there may not be a right answer in this space, and it's okay as you get meta to accept that there's philosophers out there debating this stuff forever. So the key sort of criteria is sort of Occam's razor. What is ineliminable? What can you not get rid of? And that'll be my argument for Satori as a subset of HSML, as a sort of way of bridging concepts in physical reality. And you'll see I mentioned DNS. The prior presentations in the group were for connector network systems, where you shift from domain to the interconnectivity of domains as a different approach. And I think we'll touch on that. But really what it comes down to is we want to define what a holon is, and hopefully you'll get that sense of what that is as a kind of baseline geometric form for addressing entities, both conceptual and physical. So you got through the first section here, section 2. This is getting into that Satori concept as it would relate to HSML, and I'll sort of visually show that, and then that should start to illuminate like a global augmented intelligence architecture through that sort of, as we go forward, this adaptive serialization of geometric structures. So this is a paper I wrote coming out of a presentation I did in Philadelphia in 2019. It's not 2918, it's I'm sorry, 2018. There's a typo there. But basically it's 6 concepts that should be very intuitive. Space, attributes, your numbers and words, time, objects, relations, and insights. Think of lenses or perspectives. And these, I think, are 6 handles in the classic digital object architecture. I'm going to use the term hedrons, which are seats, for a geometric metaphor of that concept, with which you can describe anything. And they actually correspond very nicely to Aristotle's elements of circumstance: who, what, where, when, how, and why. And Aristotle wrote about these in the Nicomachean Ethics, if you ever wondered where those came from, those 6 questions of interrogation related to the elements of circumstance. Now, if we take those relative to the current HSML ontology of their 12 elements, you'll see there's a direct one-to-one correlation with space and time. Those are the most fundamental native. Now, when you look for the other 4 attributes, later in the deck, they talk about the attributes of these 12 elements. And I would therefore point out that since the paper I wrote is about a meta object facility, that's a meta thing. Attributes are a prime citizen. They're ineliminable. They also talk about objects, and I'm going to advocate, you'll see, for the concept of entity, because if you take something like imports, it could be a thing unto itself, or it could be a relationship between things. Those are 2 aspects of the same entity. So objects are great. Then relations you see there, you'll see these are literally showing relationships between those 12 elements. And then finally, lens or perspective. We should always enable a kind of liberality, libertine spirit relative to perspectives. You want people to have their own way of seeing things. So now we take these 6 concepts, I map them to some geometric shapes. I think the future of the internet, this sort of internet of everything, there will be kind of prime citizens in the platonic solids. And I will go into reasons on why I've got these associations here. I'll just call out here attributes. You can see in the lower right here, the iconography. That's associated with data cubes, right? If you think of a spreadsheet as a slice, literally people talk about data cubes. Rows and columns make you can make a 3-dimensional and even n-dimensional sort of hypercube of data associated with things. And we'll come back to why these shapes approximately correspond to these who, what, where, when, and how, and why, and how they could even be visual elements to help people navigate, like with a minimal number of clicks, or you could associate voice commands with them as well, ways of rotating high-dimensional complex data. So kind of bringing these back, you can see in the HSML scheme, there's that where, when, those Aristotelian elements are there. I think there's a typo in the who and what on the bottom. I consider that a why. So there's a kind of horizontal slicing of these 12 concepts for mapping assets to these 6 concepts in this meta object facility. So I will show those here. And there's the where, when, who, what, why, and then sort of show those geometric translations where you can see now that these have this kind of correspondence. Now, if we're talking about a sort of global internet of everything, we have to talk not only about how these elements map to these things, we have to sort of think through that these mappings will be occurring on multiple scales. I use aleph or alpha here to symbolize a focus, a thing, an entity of concern, and those will have these 12 or more attributes associated with them. That thing, that aleph, also has a context, which I'm going to call the omega. And omega could be a variable scope. It's just your outer shell associated with a thing. And beyond that outer sphere and that sort of focus, there's that intervening space of other things and that context of relevance to any given thing. These could be economic, industry, or local systems, like zip code, geofence type phenomena with the internets of things. And all those taken together, and we'll talk a little bit about this sort of mega omega, right? What I'm going to call the Earth 8, right? Earth Omega 8, we'll talk about in a second. But imagine like a hypothetical 0 point at the center of the Earth, and then you can kind of start to address any given thing relative to everything else. And the whole point of this is we're facing some wicked problems. There's the classical description of it on the left. And what I'm proposing here is that this schematic becomes a complexity simplifier, where you end up with a series of characters which allow you to express things very robustly, give identities that are very robust in ways that are sensitive to the types and surfaces of complexity. And then you can take those and you can tile them in a sort of self-organizing, emergent way onto these complex lattices that groups of users decide consensually agree to being a set of parameters. So for example, there's like 230 countries, each one of which would pick an address in a scheme and agree, this is my address, and they consensually agree to that lattice, and that becomes a foothold for the superstructure, much in the same way ICANN creates, designates domain servers, and that creates the internet. So this is one's oriented towards complexity and entities instead of words. So in that sort of hypersphere of like a planetary E omega 8, you see it on the lower right, we can immediately call out that there's probably 7 scales correlating with trillions, billions, millions, thousands, hundreds, tens, and ones. And if you put a individual in the focus of that middle, the whole superstructure will shift focus, right? Each person is part of tens and hundreds, and there's different lenses on that. Do I see myself as a community or a member of an organization? At that outer envelope, we're all members, right? We're pixels on a larger kind of screen. And I've called out there 2 lenses. One is a great diagram of the world economy of 104 trillion. And we're at that purple sphere, the outer sphere, as well as kind of the 54 trillion of systems and the need for 4 trillion to sort of fix these systems to make us kind of climate intelligent as a planet. So that kind of ends. Before I end that section, I want to get into the actual serialization concept. There you'll see I'm using basically 5 of 8 positions where ideally you can take any named thing, person, place, or thing, and you've immediately got a signifier. And it could be rudimentary, just saying a name, invoking the name, or you can signify whether it is a instance or whether it's a set, and so on. There's value, intelligence, and trust. Is it a concept? Does it have an economic, like a skew or NAICS code? Does it have a geographic location, a social location, like governance-wise? And then I've left 5, 7, and 8 open, and I'm throwing in currently the Satori, where is this a space? Are there attributes about it? Is there a time dimension, a start and finish date? What is the object aspect of it? What are relationships between it? And what are different perspectives on it? Those all become embeddable in a single string, even though they're a graph, and you can create a URL, universal resource locator, or global resource locator out of something like that. And I'm doing a little bit of hand waving there, but we'll shake that out. This shouldn't be too unfamiliar to people, and I'm going to just touch on serialization here. We have these in QR codes, and each of these are inter-expressible. You can take each one and translate it to another. QR codes, skews, and then even the dollars have these kinds of numbers on them. Where currently, I believe they're random, except for the letter. One of the 11 digits shows which district the bill was published in. But you can imagine tokens themselves having identifiers which could be tied to agency intent through smart contracts or physical assets in this kind of manner. And these are also hashes in effect. And you could chain them to capture state changes over time. But yeah, without getting too far down into this, serialization is really kind of the Archimedean point from which we can really do a lot of, it's used in amazing and critical ways all throughout sort of technical systems around the world. And what I described as a meta-object facility is sufficiently abstract that anyone conversant, it's a test of its ineliminableness, that anyone conversant in any one of these serialization methods should be able to find those 6 concepts ready at hand, right? They cannot function without having those 6 concepts ready at hand. So therefore, calling them out as a sort of meta-object framework to socially agree to and then institutionally sort of adhere to becomes a convention, a really low impact convention to allow the optimization of these serializations and connections even across each other. So it's also stack agnostic. You could do it in binary and you could do it in text. So kind of wrap up the serialization before we go on to the math section. You take these 6 things, which you'll see I've got above it, that this corresponds to sort of a single, dual, triple aspect, which would be kind of your base footing into lattices that will then allow for crystallography at those associated dimensions. So you end up with a superposition of an entity that has these aspects that creates this 3-dimensional shape, which becomes your basis for adaptive serialization of an entity. That entity then is connected to a larger scale grid on which you can add all your super intelligence and all your cool things. Suddenly have handles which are even transnational, but transfirm, right? Where standards have that magic of helping people solve problems that they can't solve individually. So coming next to the math part, I'll try to get through this quickly as possible. I'm just going to kind of present it as teasers, but essentially this is really critical to the standard. It talks about hypervoxels, really great concept of sort of defining an entity as a set of vectors. And I'm going to be kind of advocating for this notion of simplexes being this sort of prime meridian from which you sort of build up dimensionalities. You should stay as simple as possible for as long as possible and only go to greater complexity if you need to. I'm going to talk about sphere packing, and that's kind of a bridge to the Euler aspect, where the spheres are kind of the primitive geometric shape, and then articulations on those give you more handles, or again, hedrons, surface like seats, from which different systems can grab different Merkle entities or chains. And then finally, this sort of exceptional Lie algebra, right? That's the, imagine, the World Banks simply say, we're going to agree to an E omega 8, and that becomes the basis for carbon, eliminating greenwashing, where we now have an address for every molecule potentially of clean air or water. And I'm not going to get too far into the hedrons, the adaptive serialization part. That's going to be later. But the key is to introduce this sort of geometry. Simplexes are the easiest thing here. They're just basically the simplest shape you have in each dimension. A point, a line, a triangle, and you see it yellow, the tetrahedron. You can kind of still see it there if you imagine this line in the back is being kind of the back of the tetrahedron. You can see it. Then you're up to 4 dimensions here and so on up to 8 dimensions. But you can see this as kind of a hyperspace, where as you define each of these dimensions, as you add them, you can add more sophisticated surfaces and volumes for more sophisticated contracts and relationships and functions. So now moving to sphere packing, this is something Newton thought about. What is the maximum number of spheres you can pack, unit spheres in any given dimension? So like on a line, you can get 2 associated with a sphere. On a plane, you can get 6. In a 3-dimensional space, you get 12. In 4 dimensions, it's 24. And on the left, you'll see this is a diagrammatic representation that we actually don't know still in all this time, in this 300 years since then. We don't know exactly what the number is. For many of these, we only know the range. This is what's represented over here. But we do know 240. And going back to E8, we'll talk about that, where in 8 dimensions, you can pack 240 spheres around any given sphere, which has really fun things to think about, right? That I'll posit that potentially, if you have a problem, if you have more than 240 variables, you can apply Occam's razor. No problem has more than 240 aspects to it. That's a pure speculation, though. But here I want to kind of walk you up to sort of call out different aspects of this, where here is just one sphere. Here's the 12 spheres packed around it. And by the way, that represents that 12 spheres packed around the single sphere in the middle. That makes what's called an icosahedron, a 20-face geometric platonic solid. This is one of those symmetries that are going to be very critical in the future metaverse, internet of everything. Now, notice what I did here is I put kind of a recursive fractal, where I'm no longer going up the simplex. I've stepped off of it, and now I'm adding kind of recursive nested infinity here, where if I say there's an E8 for the entire planet, a unifying one, I can take any given point in that lattice and I can create a recursive E8 on that. So there's no limit to this kind of system, and you can kind of keep going. You can see kind of keep going down. It starts to look like a fractal. All of this that I just showed is all just over here. So these could be, in a sense, spaces on spaces, where you have a zip code in a city in a county in a state, and so on up, where you could be looking at the world and dial your degree of granularity up and down just by saying, show me purple level, show trillions, or show me yellow, which I think is about hundreds, and you would see different levels of granularity depending on your CPU. But this is all just one. You would also, each of these points can have lattices corresponding to them associated with these. These all have different lattices associated with tilings of 3D and higher dimensional spaces, which we'll touch on next. And that's vertices, edges, faces, and cells. So Cool bit of information to know, up until 1750, people only talked about faces and points when they talked about geometric shapes. No one ever talked about edges. And Euler came along and said, okay, what about these edges? And in so doing, he came up with this formula on the lower left, or lower right, where if you subtract the number of edges from the number of vertices and you add the number of faces, you end up with 2. And that's a special case just in 2 dimensions. That's extensible if you add the inside and outside of the lower dimension to it. It will give you the value equals 0. So bear with me. So now let's walk up that ladder, just get orientation, where on this simple level, you should be able to explain to anybody triangles are value. So all value systems would exist as triangular matrices. So if I'm at point A and I want to get to point C in value, I can go through pathways that would be defined by those 60-degree angles. Then, so value we could reserve for triangles, and these are the sort of social convention policy assertions / discussions to have, where data goes well with that data cube, right? This would be kind of basic data intelligence about things. Identity, I think, goes well with pentagons, and hexagons would be kind of your lattice network of relationships. Again, this is somewhat arbitrary and obviously fun to talk about, but there is a certain constraint implicit in geometry where these are basically the, if you think of tilings of mosaics, these are the base primitives. I think there's one more. There's a total of 5 that you can create all crystallographic groups out of. And so these are embedded in chemistry, they're embedded in molecular science and stuff. But you got to be really careful what we end up assigning these to. What do they mean? And then, because then you start building up from these simple primitives where that Euler characteristic applies, you get to the 3-dimensional space where, again, it comes out to 0, and you can see our triangles are kind of associated with these, the squares, pentagons, an identity and defined by relationships, and the DID, decentralized identifiers, and then sort of this notion of spaces upon spaces, 3-dimensional spaces. That now gets into the fun stuff, right? Where we're evolving still. Maybe our descendants will be able to see the 4th dimension, right? That raises all sorts of fun questions, but you don't need to see it to imagine having these kind of higher order spaces from which you can model systems. And if you look at things like deep learning and such, there's some really fascinating work going on around kind of graph, and arguably all information can be reduced to data about things or relations between them. And you start to see that surfaced here, where you could create these sort of hypermanifolds using this geometry. And these will be, again, kind of primitive, kind of home base, kind of orientation neighborhoods. These geometric forms, enforcing data to fit to them, acts as a constraint that is, in effect, a counterpoint to chaos, right? We have the rigidity of symmetry, and then you superimpose it with the elasticity of free-form total information, right? You think of it, you get your muscles, the free-form, working against the scaffolding, the fixed nature, which people can then make assumptions from and share. I'll call out this sort of E8. It's going to be here, up to the 8th dimension. I think that might be enough, 8 dimensions. We'll talk about that. I won't necessarily, that's something I'd love to talk about with people interested in this and learning about this stuff. But there's a whole, I'm going to go back to that slide. There's a whole bunch of, think of these as like a periodic table of really incredibly potentially useful tools all in here that come naturally once you agree to that Euler characteristic. That one constraint gives birth to all these exceptional Lie algebra structures. And there's additional ones in that too. This extends beyond that. But the ones I think are really interesting are the ones that are built on those really simple geometric primitives, where I've mentioned this E8. It has tetrahedrons, cubes, octahedrons, icosahedrons, and dodecahedrons as subsets, as subdomains, or neighborhoods or regions within. This is a depiction of the E8 here. And it also has a toroidal infolding. If you look up the Hopf fiberation, it's really incredible. I think it's a beautiful mathematical representation of the flow of money and value and monetary global to local systems, or just any arbitrary system could be probably mapped as a Hopf fiberation. But here I'm just going to let play a really pleasant rotation. If you've ever seen a sphere move through a plane, that's effectively what we're doing with an 8-dimensional shape, where here you're kind of seeing the larger aspect of it. And as you move through it, you see different sides or perspectives where more or less becomes visible depending on your vantage point on the system. And as we get down, you'll see it can get incredibly simple. Like there would be industry data. Now we get down to effectively GDP, inflation, and then simple as that. What are the 6 most important concepts in a system? And then you can sort of work your way out where we can use AI to actually curate, dedupe, and align to what is our collective knowledge graph on associated domains and how do those interlink. And this would literally be visualizable in these giant large-scale lattices and 3-dimensional interfaces. So that's the E8, and I think that's a good candidate for guardrails or rails for an Internet of Everything. Just to call out here, you can see there's the E7. These are, in a sense, they're all named and well understood. These are all down to, there's like 600 million points in this. If you identified every point, which is essentially the center of a sphere, which combine together to create this shape. It's all sphere packing. This all lines of sphere packing. Those are just addressable addresses, right? Where there's a finite number of them and they have all these sort of really wonderful structures. I'm getting carried away on this. There are people who obviously know far more about this. I apply here just this idea of like, oh, what if you want to create a consensus avatar for people where they would debate? You could call out different types of relationships. I'm not going to go into too much detail here, but you have a consensus mechanism embedded in all this. And one way of kind of visualizing that, you can imagine something has not been engaged, or people are voting, they're pro or against, and you could create these sort of lattice consensus systems. And there's some interesting math associated with optimizing those for those. But I kind of went deep there. Let's kind of pull back. This is just sort of imagining the flow of data in the world as it goes around to different things. That's great. I'm suggesting we throw this sort of geometric shape at it, which we're now done kind of talking through. That then gives a kind of scaffolding or skeleton onto which you can start to map your data. And that gives you really cool superpowers. For example, here, I mentioned 240 countries. Each one, once it asserts an address, now has a location relative to other. So immediately you get this superpower of a distance between relative entities in that grid, right? And so this is really powerful. Another way of looking at that is you can start to define not just distances between individual nodes, but you can start to define kind of spaces or sets of those nodes and combinations of those nodes. And that moves you into another aspect, another area where we can start to compare different things from an ESG perspective, or different allocations or footprints and so on. Going one step further, now the transaction aspect of it, where we can do multi-party secure computation, where we can choose to see aggregate positions, which would be represented between like a snapshot, like right about there, right? Where you have a very simple view of like a snapshot of state, where then things would move freely beyond that. And you would not sort of, you could keep that individual liberty while also having that jurisprudential oversight of systems and different allocations of that jurisprudential system in a sort of integrated, interdependent, independent way that's transnational. So moving on from there, another visualization, and I'm gonna let you enjoy those. I got links to the source paper for that. And just calling out that you could invoke these different shapes that would define those neighborhoods. I think I've covered this, overcovered it. That's a slide I was going to delete. I'm going to skip through these, kind of trying to build that ladder. Here's some good reference materials, including the link to that movie I showed is right there. And then there's some stuff on the kind of Clifford algebras associated. This is really a good foothold in it. And then more stuff on what E8 is. All right, so sorry about that. I think I spent too much time on that, but just going to the next section, the 2.2. how do we sort of tie that geometry to these protocols? And this brings us back to sort of the concept of the entity or the holon, and how do we visualize that? And not just visualize it, but map it in these geometries. And do so in a way that isn't supporting just objects, but also relationships or those connector network systems where you specify rules for connectors and don't worry about the endpoints. That'll be critical for the interdependent aspect. But you can see any given holon is like an apple, where I would have that center of what it is as a focus, its outer bridge, outer shell, as a series of nested potential spaces that could have 7 or more. I'm picking arbitrarily this Roy-G Biv 7 here, but that's those are conventions that people could agree to in these lattices. And they would then be mapped by these dimensional vectors, where essentially you have things like causation, dynamics, all kind of captured in defining the position of an entity, super entity, mereological classes or groups of entities in all sorts of different fun and fascinating ways. It could be relative, like perspectival in terms of role-based access. You could have that superpositions of those to have different people do, like auditor functions and supervisory functions and on these sort of multi-scale multi-party compute data sets. And that kind of calls out these 6 things. It's not just in isolation, you can view them in combinations, and there's a finite number of combinations that would then sort of limit the algorithmic impact of doing analysis on these kind of lattices. And everything I've been talking about ends up sort of calling out this idea of like a meta-works, or whether we like it or not, or want to acknowledge or not, we all kind of work on the planet and therefore for the planet potentially. So one could imagine a sort of aggregate work entity. I think you need to, for getting to sort of planetary intelligence, you need to define a kind of meta-works. And that would be an abstracted lattice on top of the meta base, which is the sum aggregate of this techno-social infrastructure, right? The cloud, people making decisions and interactions between them. And so you have these two sort of outer kind of carbon and silicon based functions, which agree to sort of an entity scheme that maps to spaces and agency within spaces. And that scaffolding, that entity focus / omega content container aspect becomes a fabric on which you paint your data, your metadata, and modeling that data in sort of consensusly curated public knowledge utilities, data fabrics that could be shared or preserved privately, or ideally kind of a mix. That data then can be supporting models, and this is where you move beyond Alexa and Siri to public utilities that would allow for public AI. People can create their own AI, curate those AI, vote on the AI, work together and build kind of a Red Hat Linux model of public AI that services different functions relative to different transactions. But that model layer would rest on top of that. That would help with value. So if someone does a transaction associated with a washing machine, it would, in a sense, connect to every washing machine on the planet, the data associated with them, and then also the supply chain to unpack the different costs that may not be currently factored associated with the impact of a device or thing or purchase. So you get these value lattices where the future of digital money may be more like an internet of money, where your ownership of a coin is really just an impression on a surface or manifold, which is kind of world encompassing, right? That's how you have digital currencies running off a platform in a marketplace in Afghanistan using a digital dollar, which isn't running on like a FedNow or something like that. So there's a few more here. The graph, right? The marketplace, like how do you ensure you have instantaneous access to the world of data on price associated, including geolocation, transportation costs associated with any given entity? That'll be a kind of part of that graph, which I tend to think about them in terms of knowledge, but would also work for commerce. And like imagine, effectively it'd be like an Amazon that was public, where you just lift anything up and say, I want to sell this, and it gets announced in a planetary marketplace. Same with sort of this meta-us, where if you think of each individual is composed of different intents, you could stitch those together to get this sort of meta intent, which is going to be critical to making sure, that the dystopian futures of the robots running the world, we all have like a kill button in effect. And that kill button has nuance associated with different surfaces of engagement and beliefs. But those should all be allowable in a policy agnostic way. Here and then you go from left to right, you start to see some sort of visual articulations of what manifestations of each of these grids based on Satori would start to look like. These would be visual iconographic things that people could talk about, handle, and interexchange and actual use as reference points across different systems in that metabase. And they're sort of a representation of it. You have this sort of encapsulated shell, this metaworks running on this metabase, and that's referring to these lattices which help reduce the friction, so to speak, in these not just localized systems like markets and meta models, but transits between them, the interlinking between them. And that finally brings, I think this is my second to last section. This is a pretty easy one, just talking about, okay, that sounds fun theoretically. Well, how do you bring it into practice? And I'm going to touch on that really this is a time when you need to be doing systems of systems engineering. You can't just be doing systems engineering anymore. And the good example is if you think of an airplane at Boeing, no one person can understand the complexity of every bolt to the jet engine to every aspect of it. So you have to design your systems to be holistic. This kind of supports that, where, it could be systems nested on systems. There's good rules of practice associated with that. We need to think in terms of hyper utilities like HTML itself, like wikis, Wi-Fi. And in order to be a hyper utility, there's certain properties you need. And this is basically just extending HTML up a layer to be that Internet of Everything. And you see there's sort of representations of that. Finally, there's this digital, well, it's not finally, these are the three architectures you need. Robert Kahn has this sort of digital object architecture, which if you go to universities, you see DOI in the URL for documents. That's the universal identifier. It's used for documents. There's no reason we can't use this architecture. It's worked for 40, 50 years. No reason we can't use it to extend this Internet of Everything. It's a good, and you'll see I introduced entity there as opposed to object. It's a digital entity architecture. Then I think the decentralized autonomous organization is the best sort of articulation of multimodal relationships between entities. Like you if things are owned, they become trivial. If things are like clean water and air are kind of multi-ownership, that's where you get this sort of distributed autonomous organization schematic being kind of fundamental. Especially if we're going to end up with a planetary town hall, which is probably the manifest sort of destiny of the internet, is we'll have that where we'll all be pixels kind of swarming in different matrices representing our intent, articulating as giant avatars that would kind of express our collective intent. But yeah, there's a great paper here which gets into civil resistant, privacy preserving strategies and architectures for what is essentially an optimization of democratic values in that metaverse. Finally, the DID. This was just approved as a W3C standard. This breaks us out of the flaw with the internet back in the day with identity certificates being binary. We now get to this wonderful place where they're n-ary, and you can gather credentials and assert identity while controlling your information outflow. So DIDs are really fundamental to all this, especially preserving autonomy in interdependent systems. So that's pretty much it. Now just to the applications. I went double the time I had during the actual presentation. I still think a lot of these things I could talk obviously for too many hours, so I apologize, and thank you for listening this far. This is really the punchline, and you hopefully you skipped here maybe if it was or multitasking, but where do we end up? That's the sort of fundamental driving question. Almost every deck should have that slide. This is based on Kate Bosworth's sort of donut economy concept, where right now, like the United States, it's 5% of the world's population, yet we account for 40% of the impact, the environmental impact. We're outside the circle. We need to move inside the circle, onto the circle. Other people in other nations are falling short. If you don't have clean water or sustainable economy or housing or political voice, you need to move up to the circle. So the hat trick becomes, how do you how do you keep economic well-being while transiting to a sustainable economy. I think something like this E8 you see kind of superimposed in the back there will be super helpful. And that Society 5.0 architecture, again, this sort of, I think the best articulation of a sort of open economic commons is captured once you establish the serverless technical foundations for running systems in a way which are like the internet, more like the internet, less like America Online, AOL, where we tend to be designing systems to be platform-based. They should be designed as open systems. And this is a kind of first pass at articulating the essential components that you would need to build something like that. And you see it kind of mapped there. This then kind of leads you to, oh gosh, we'll have this holographic interface where we could see, each of us can see the whole that we are participants in as parts. And you'd have these learning machines helping us running on these shared graph databases with that sort of secure compute. And we were shifting with this atlas concept to that sort of planetary digital twin, where instead of doing fragmented data insights, we're working on integrated holistic digital twins of systems. You see that's kind of represented there. And just trying to wrap up, avatars. This is really important. The Finance 4.0 paper that's linked to there out of Switzerland, amazing paper that really does a great job articulating a sustainable economic structure that's community sensitive. Really just good stuff. Really encourage you to read that and to the point where you understand that diagram. It's pretty mind-bending. But that avatar there, I like Benny as a sort of cartoon representation of our collective will, which is what a proxy for an avatar. Finally, drilling that avatar, we have our collective will embodied in this sort of planetary smart economy. How do you get it down in that atomic layer? Well, you use algebraic topology in the paper down below, which would allow us to express that donut into every coin, every identity of a cup, SKU, or SSID, or legal entity identifier, right? You would have this lattice of consensusly curated, agreed or disagreed debate data associated with any given entity at any taxonomical or mereological sort of aspect of systems. So I think that's getting close. I got 4 more slides. This one's kind of evocative. I like these animations where you've heard me talk about the Satori protocol. This is showing the atlas, the idea on the left of kind of modeling, that illuminating the collective self, right? That each of the points there would be the part of the collective identity of a nation, region, or planet. And on the right side, you would have this kind of flow of function across that intent structure. And that would be the Gaia, the global augmented intelligence architecture that would leverage the atlas to express the avatar's will through the Satori protocol embedded in different entities, in coins and such. So I think this is the second to last one. This one, I think it's really helpful to think. We do a really good job with data information. Articulating that shared knowledge structure will be critical. And then we have these instant access to insights. So I think that's good. And then I think you've made it to, there's just 2 more slides. I think this is important, that sort of token ledger distinction. It's not referenced in this paper, but that's a good paper on that. And then some observations. This is specific to the HSML. So with that, I went over time. I'm at 48 minutes. Thank you for your time. I really appreciate it. And definitely encourage you to sort of reach out. Send me an email at mike@eureekworks if you'd like a copy of the presentation. And I'm not making this public, but I'm just sharing it with friends. Feel free to share it with a friend, I guess, that you think might be interested. And thanks for your time and attention, and look forward to possibly exploring some of these ideas with you.